If you're a space nerd, and I'm guessing a lot of you are if you're listening to Wild Thing, February 18th, 2021 was a big day. At 3:55 p.m. Eastern Time, after more than 6 months and 300 million miles, NASA's Perseverance rover landed on Mars to begin its search for signs of ancient life. Now, we've been captivated by the idea of life on Mars for centuries, and the planet itself has long fascinated scientists like Sarah Stewart Johnson. She's a planetary scientist at Georgetown University and a visiting scientist with NASA's Goddard Space Flight Center. She's also the author of The Sirens of Mars, Searching for Life on Another World. Sarah participated on the science teams for NASA's Spirit, Opportunity, and Curiosity rovers. And while she's not directly involved with Perseverance, she knew exactly what everyone was feeling on the day this newest rover hit Martian soil.
Terrified, excited, hopeful, just a million different emotions. I think I was feeling maybe slightly less worried than I was when Curiosity was landing. That was the very first time we had ever tried this sky crane technology, which is kind of like sending a rover down to the surface attached to a jetpack. It goes down, the parachute deploys, the rover drops down on cords, and it gets put down lightly on the surface, and then the sky crane powers away and crashes in the distance. And we'd done that before, and it had worked. But there were new things this time around that had never been tried before, and so it's always a little bit scary. And it was just flawless. It was within 5 meters of that target after a 292 million mile journey from Earth. It was really incredible.
I mean, it blows my mind. The engineering that goes into this kind of mission, and all of these missions, it's really a marvel. And I imagine it was an incredibly exciting day for you and for everyone interested in space and life in the universe. Can you tell us a little bit about the mission?
Perseverance, it's kicking off this breathtakingly ambitious campaign to collect samples of Mars and bring them back to Earth, which is going to allow us to ask these really fundamental questions. I mean, we hope about, are we alone? And is there life in the universe? And so basically, Perseverance is going to spend the next 2 years exploring this place called Jezero Crater. And there are all kinds of really exciting targets that could potentially hold the traces of ancient life. And it's going to collect samples, at least 20 of them, but maybe even double that number. And they're each about the size of a piece of school chalk. And those samples will be cached and left on the surface. And then we have to wait. The idea is 2 more missions will follow. One that's a fetch rover that will come along and collect those samples and put them into an ascent vehicle, which will shoot them up into orbit. And then finally, another mission which will come and collect those samples and bring them back to Earth.
Geez, that's a lot of missions. This project is incredibly ambitious.
Yes, there's no shortage of that. Even the scientists that were planning it, there was something called the Science Definition Team many years ago, and this concept of sample return was just really being seriously studied for the first time. And they came up with these decals. You may have heard the phrase, go big or go home. But those decals said, go big and go home.
I kind of want one for my car. So what's your role been with this particular mission?
Oh, so I'm not part of the Perseverance team. I'm working on Curiosity, which is a rover that's exploring another crater called Gale Crater up on the surface of Mars. But I really hope that my lab is one of the labs that will be selected to analyze these samples when they get back to Earth, to search them for what we call biosignatures or traces of life.
That's incredible. So you mentioned that you picked this crater, the Jezero crater. I'm interested how we ended up choosing Jezero specifically.
It was like a fight to the death, Laura. I have to tell you. There's nothing more impassioned than these landing site selection meetings. So we think Jezero is about the delta, the main scientific target, this exquisitely preserved ancient river delta. We think it's about 3.6 billion years old.
Wow.
And we know that actually we use those craters a lot. We have these statistical models about how many craters should hit a surface over time. And so places that have been resurfaced don't have as many craters, and places that have a lot of craters are older. And so that's kind of how we can do some of the dating there. So there were dozens and dozens of sites that were initially proposed, and then there were a bunch of landing site selection meetings, and I went to all of them, and it was just this huge fight. Should we go after ancient hot springs? Should we go back to a place we've been to before with the Spirit rover, where we have so much knowledge already about, the best way to explore? Should we go to a place that might harbor a completely different type of biosignatures or traces of life? Should we go to a place that might have, these really deeply, exhumed deep crustal rocks that we have pulled up from the subsurface? Or should we go to a place like Jezero, an ancient lake where we have this beautifully preserved river delta?
How do we know that was there? How do we know what ancient Mars was like?
That's a great question. And so one of the reasons that it's so exciting to explore Mars is because it's all ancient. We are looking at a surface that time has kind of stopped. So there's still aeolian processes, wind moves things around, but the really dynamic, vital world that Mars used to be it's sort of gone into this deep freeze. And so around the time life was getting started here on Earth, Mars and Earth were really much more similar places. We had liquid water coursing around on our surfaces. We had a protective magnetic field that deflected the solar wind, which allowed us to keep these warm greenhouse atmospheres that blanketed the surface with warmth and helped regulate the climate. So it was much more habitable sort of world back in those early days. But those ancient rocks, those have been preserved on the surface of Mars in a way our history has been completely lost here on our planet. And so a big part of that is plate tectonics. We think we never really developed global plate tectonics on the surface of Mars. And so here we've just kind of swallowed our past plate by plate. Like so many of those ancient rocks have been pulled back into the interior of our planet. Whereas on Mars, they're all just there on the surface. And then we also had so much fluid erosion here on our planet. And the reason that Mars is covered with craters is because none of those have been sort of worn down and haven't disappeared. And so as a result, we have this geologic record on Mars that preserves that time. That time where we went from an abiotic planet to a potentially biotic planet.
That's amazing. So do we know what happened to Mars? Do we know how it lost its atmosphere and became the planet that we know today?
So we do in sort of broad strokes, but there's still tremendous mysteries there. So we know that Mars lost its magnetic field probably sometime between 3.7 and 4.1 billion years ago. And so our core, we have this convecting core here on Earth, and that generates a magnetic dynamo, and that creates a magnetic field. And that magnetic field is great because it protects us from the solar wind. It allows cosmic radiation to be deflected. But what happened was on Mars, because it's a smaller planet, that core sort of started to freeze out. And at some point, that convecting core that we know it had early in its history, because we see these magnetic terrains preserved, especially in the southern hemisphere of Mars, it just died down and that magnetic field went away. And that was a big turning point for Mars, because then slowly the atmosphere was sputtered away. And without the atmosphere and without the greenhouse gases, the surface got really cold. And the pressure was so low and the temperatures were so low that liquid water could no longer exist on the surface in liquid form. It would either be sublimating into a gas or it would be an ice in ice form. And so basically, at that point, it became a lot less habitable and a lot harder for life. But there still is this possibility that life might have retreated into the subsurface where it was warmer and where there's still, spaces, like pore spaces between minerals and even larger things like lava tubes that are carved underground. And it might be a place, if I was a little microbe on Mars, that's where I'd like to go.
At what point did we decide that Mars's subsurface was worth further investigation? Was there a particular finding on Mars or here on Earth that made us think we should go below the surface?
I think, as has often been the case, there was this moment here on Earth when we realized that just a vast amount of biomass was beneath our feet in microbial form. And so much of astrobiology, you see this really kind of fertile period through the 80s and the 90s and the early 2000s when we did start going into these extreme environments and realizing that, the limits of life were much broader than we initially thought. And part of that was realizing that there was a lot of biomass underground. And I often think about this when I think about early Mars, like if life, and I'm thinking, simple microbial life, if that kind of life really took hold on Mars, I just think about everything you'd have to do to just to autoclave a planet to really get rid of that. Can you imagine trying to get rid of all the microbial life here on Earth, even if the climate changed, even if, the surface kind of became a sterilization chamber because of the radiation? I think that life would retreat, life would find these niches, life would adapt. I think that we realize just how stunningly resilient life is here, and it gives me hope for looking in places like the subsurface of Mars.
In reading your book, it became apparent that there's been something of a pattern of things not being what they seem or what we want them to be on Mars. We were sure there was intelligent life. There wasn't. We could see, spoiler alert, that we could see oceans and canals and plant life. And we were wrong about all those things too. And this is a planet that's gotten more attention probably than any other except our own. Do you think we can still expect more surprises?
Yes. Yes. I mean, I think if there's anything we've learned from the history of Mars science is that it's full of blind alleys and twists and turns and just the most unexpected things coming up. And I think it's partly because Mars seems so familiar. It is the closest planet we found in this whole universe to Earth. And, we look out and it looks, like Wadi Rum in Jordan where they filmed The Martian, or it looks like the middle of the Arizona desert. It's familiar. It's a place you can walk around and scrape your knee. And I think that time and again, we've been just bowled over by the indescribable foreignness of this place. Mars is truly alien. And I think it's just been very, very hard to get that into our heads. And I think that we're still making some of the same fallacies when we approach life detection. So much of our work and, so a lot of my work too has been focused on these kind of traditional biosignatures, the traces of life that are familiar, the kinds of things that we found here on our own planet when we go back into the ancient rock record. But I just think that we're slowly as a community really coming to embrace this idea of not just life as we know it, but life as we don't know it. And so a lot of my recent work has been in that area, trying to think about how we can come up with different tools and techniques to recognize life, even if it doesn't share the same molecular framework as life on Earth, or if there's a different kind of underlying biochemistry.
Yeah, the analogy I heard several times was that, you start looking, if you lose your keys in the middle of the night, this place you start looking is under the lamppost because that's where the light is. That's where you can see. And in a similar way, we're looking for life as we know it because that's what we know how to recognize. But at some point, you have to step away from being under the lamppost and go after some things that might not seem plausible.
Yeah, I think that's right. And such a nice way to put it, but I think that's right.
So over the centuries, as we have been sort of looking at Mars through various telescopes and trying to see it in a lot of variety of ways, there have been a lot of myths that have cropped up. And one of the most famous is that Mars had canals. Can you talk a little bit about this belief? Because it's probably one of the ones that people might know best.
Sure, yeah. So the canal hypothesis. So this was, so canals, this idea of canals, it really started with this Italian astronomer named Giovanni Schiaparelli. And he was doing observations back in 1877. And every 26 months, Mars and Earth align on the same side of the sun, and there's a good viewing opportunity because the planets are so close. And he had been doing a lot of work in other areas of astronomy, but one night, when Mars was particularly close to Earth, he got his telescope up on the rooftop of the Brea Observatory, and he pointed it at Mars. And what he saw really perplexed him because what he saw he could not match with the existing maps of Mars. So he started drawing his own maps, and he was drawing Mars with these linear features. And he called them canale, which in Italian means channel. And I know there's been some debate about this, but, the sort of common idea is that got mistranslated when it came into English as canal, which is a different thing than a channel, right? But actually it went through France first. There was another astronomer called Camille Flammarion, just a very flamboyant, fascinating character. But he was writing this book that was compiling all the data on Mars up until that point. And he published in the early 1890s, but he talked about these linear features on Mars. And of course, at this moment, big canals were being built here on our planet. And there was a little bit of a leap, like, well, of course, why wouldn't there be canals on Mars? But this didn't take hold in this sort of big global way until this idea got into the hands of an American named Percival Lowell. And he just got so excited, just electrified by this idea of canals on Mars. And canals that covered the entire surface that to him indicated, some sort of benevolent oligarchy had taken over, and it was this advanced civilization, and Mars was a drying up desert, but they were irrigating the planet, bringing water from the polar caps down to the equatorial terrains. But he just got so excited. He went rushing off to Arizona, built his own observatory, and started writing these books that were flying from the shelves. And there was this period around the turn of the century where much of the literate world actually thought life had been discovered on Mars in the form of these engineered canals.
I mean, it took almost 100 years to dispel this idea. Did that affect the study of Mars? Did that make it harder to get to what was actually up there, sort of slow down progress?
Well, so one thing to know is that planetary science sort of drifted into a bit of a backwater in the early part of the 1900s. Astrophysics was coming up in a big way, the theory of relativity, like a lot of new discoveries, of things that were very, very far away. And so planetary science was limited by the fact that telescopes just kind of had gotten almost as good as they could get. And there was a phase change, I guess, when we discovered space telescopes and the idea we could get a telescope above our own wobbling atmosphere. So planetary science was in this really strange period. And even as people started dropping the idea that there was a civilization on Mars, this peculiar idea that linear features were still somehow part of the surface did stick around. And you can see evidence of that even into the 1960s. You can look at the planning map that was used to figure out how the first flyby missions of Mars that were launched by NASA and arrived at the planet in 1965. You can see those linear features just eerily coming out from these planning maps. And there are no linear features on Mars, but I think it's just this trick of the human eye trying to connect these disparate features, especially at great distance. And some recent ophthalmologists even have suggested that, we might be catching traces of the faint retinal webbing in the back of our own eyes.
Oh, whoa.
Kind of seeing our own ghostly image as we're looking out.
What do you think's going to happen in the weeks and months ahead? For someone who hears this interview a year from now, what do you think or hope that we'll know by then?
Oh, well, I think I would I would encourage patience because it's going to be quite a while. So, it'll be at least 10 years before we get these samples back on Earth. There are these 3 missions that have to happen. We're thinking about the 2030s. And while I won't say it's impossible, I think that, the way the payload is set up on Perseverance, it's really designed to collect samples. I don't think unless we really hit a smoking gun, we're going to have this aha moment next week, Perseverance finds life. I think that even though it is the goal to finally look for life, to go after biosignatures, I think we do need to be patient. I think that every time we touch down on the surface of Mars, we learn wonderful new things. We've got at least 2 years coming up studying Jezero Crater. And then we're also going to have other missions coming up in the next couple of years. One I'm particularly excited about is the Rosalind Franklin rover that's going to be launched by the European Space Agency. And they're doing this mission in collaboration with Russia, but the rover that they're developing is going to drill down into the subsurface a couple meters below that basalt in a place called Oxyaplanum. And we'll be doing in situ science, looking for things like complex organic molecules. And so there are all kinds of things on the horizon.
So, and when you say they're going to be doing in situ science, are they going to be able to analyze that material and send results back? Or is this another situation where we're sort of waiting several years, maybe a decade, for another mission to come in and pick up samples and take them home?
That's a great question. And so, no, though, all of their instruments are designed to work on the surface of Mars and relay their data back. And so Perseverance also has in situ science. Perseverance will be looking at lots of things about the context of this site. Will help understand the geology of Jezero Crater, its ancient climate. We'll be picking up lots of clues. But yeah, the Rosalind Franklin rover has no sample return associated with it. It's all in situ science data beamed back as soon as it can.
Yeah. This is, Perseverance is the latest in this long line of amazing missions that have happened. The first one being Mariner 4, correct? Back in the 1960s?
Yes, the first successful one. Yes, it was in 1965 in July that it flew by Mars, and it took a handful of pictures, and it was the first time we saw the surface of the planet.
Technology has changed so much, and our knowledge about Mars has changed so much. Are there any similarities between those 2 missions, or are they just too far apart at this point?
Well, we are still using the same kind of chemical propulsion, the 321 blast-off kind of rocket. There are some new advanced propulsion, like solar electric propulsion, that we're exploring for future missions, which is exciting. But honestly, that's about the end of the similarity. Mariner 4, its computer was like a pocket calculator. It was running on just a few watts of power. It gets out there, it takes a couple of pictures, it keeps going, and the mission's over. Whereas now, we're sending these incredibly sophisticated machines that are lasting years and years and years. And, we've progressed. Initially, there were flyby missions, and then we figured out how to go into orbit. And so then we could stay there and circle the planet and gather data for a long, long time. And then we had landers with the Viking missions in the 70s. We first touched down on the surface of the planet. And then with Pathfinder in 1997, we had our first little rover. It was about the size of a suitcase, little tiny rover that lasted just a couple of months. And then now, just looking at what missions like Perseverance are capable of, it does make those early missions feel almost unrecognizable.
Yeah, it's amazing how much the technology has changed. But it gives you a lot of optimism about what else we're going to be able to do to explore places like Mars and even further out into the solar system.
Oh, I totally agree, Laura. When I think about it, when I think about Mars just a century ago, it was just this incredibly, impossibly distant place. And the idea that we would ever know much more about it than the tiny flicker of light in the telescope. I mean, the idea that we would go, it just seemed like science fiction. And that's like one human lifetime. And I think about that moment, or just that fact a lot when I think about exoplanets. I mean, they just seem so impossibly far away, light years away. And there are all these worlds that we're discovering, these exoplanets, and maybe soon we'll have exomoons that we're able to detect. And right now it seems like, well, what can we really know? Like maybe some stuff about spectroscopy, looking at their atmospheres. Maybe we can deduce a couple of gases. But the idea of actually knowing these worlds intimately, it feels impossible because they're so far away. But who knows where technology will take us? Maybe we will have spacecraft that weigh 0.5 gram that we propel with lasers that can actually reach these places. Or maybe these new developments will bring them closer than ever before. It's just so exciting to think about, even, the next generation of telescopes and all the details that they'll reveal.
Yeah. How did you first become interested in space and in Mars in particular?
No. Well, I think that the roots of my interest are certainly back in my childhood. My father's a bit of an amateur astronomer, an amateur geologist. And when I was, 8 years old, 10 years old, especially 12, 13 years old, I thought these things were, just really nerdy, and that I thought that they were his interests and not mine. But I got off to college. When I was a freshman in college, I had a professor. His name was Ray Arvidsson, and he was a Mars scientist. And I took a class with him, and I started learning about his Mars research. And then he let me work in his laboratory. And it was just the most exciting thing. And I just found like all I wanted to do was learn about these topics, and the idea of exploration and discovery and this kind of applied science where I could kind of take the things I was learning in, physics and chemistry and geology, and then go out and try to understand how a world that's just every bit as complex and enigmatic as our own, is put together and how it worked. And I think this question of, are we alone? Like, are we alone? Like, why is there something and not nothing? Like, what's our place in the universe? It started taking on new meaning, and I could sort of see how I wanted this to be the thing that guided my life's work.
Why is that search for extraterrestrial life important to you? Why do you want to know if we're alone or not?
Yeah. I mean, I think there's something kind of existential about it for me. Like, it feels hard when I think about this possibility that just the fact that we're so ephemeral. We have these limited lives, and we're born and we die, and even our planet, even our species will rise and it will fall and it will go away. And even life on Earth will end, the sun will die, the Earth will disappear, and we will not have this planet forever. But this possibility of finding kind of a second point of life just feels so tremendously compelling. This idea that it's not just us, that this life, this spark could go on and on and on. And I think that, this idea that it's just this flash in the pan, sort of bound before by an abiotic universe and bound after by an abiotic universe, just darkness and nothing, I find very hard. And here's this question that I could potentially, I'm a sort of restless sort of person, and I could potentially have an answer to this within my own human lifetime, that I could be part of this thing that's so much bigger than just myself, finding that second point of life, and especially if we found it on a world like Mars. I mean, Mars is just the next planet over, and if we were to find life on Mars, especially, a second Genesis, like if lightning struck twice just right here in our little corner of the galaxy, in our little solar system, like it would just, it would just kind of be the moment at which we realize that maybe the whole universe is just kind of a hatchery of life. Maybe all of these new planets that we're discovering are going to be home to life, but just to not sort of wonder that and think, oh, statistically, probably, but to know, because we really, at the end of the day, like we have no idea, like, is life a consequence of energetic systems? Is this nothing to something? Does it happen time and again? We don't know. And like the sort of things that we use, there are huge numbers, just tremendous numbers of stars and planets and possibilities, but we really just don't know, like how unlikely or likely is it that life actually takes hold?
It's a fascinating question and it surprises me. I think this was one of the things that surprised me most in doing research for this podcast was that we really don't understand life yet and what life is and where it comes from and how it arises. And that's the black box that we're still trying to figure out. And puzzling that out, even just for here on Earth, hopefully helps answer that question elsewhere. But even then, we don't know for sure.
I think you're totally right there. We're toddlers when it comes to this. Like biology, for all of their advances, for the incredibly tremendous revolutions we've had in this field, like it's still kind of a descriptive science. We're limited by the fact that we have one data point, one type of biology, one type of life, and all the life that we've ever discovered is the same. It's the same essential carbon-based, DNA-based life that we have here on our planet. And just the possibility of finding a second data point and just everything that would tell us, I just think it would be scientifically marvelous. Just one of the greatest discoveries of all of modern science. But there is something like in me, though, that I think does go kind of beyond just the science, even though I'm incredibly drawn to that. Like, I feel like it's more than just a search for knowledge. For me, it's kind of like a search for infinity.
That was Sarah Stewart Johnson. She's an astrobiologist and the author of the book, The Sirens of Mars. Personally, I think it's a great book, and the New York Times agrees. They named it one of their 100 notable books of 2020. If reading it makes you want to find out more, you can keep tabs on Perseverance and the other Mars missions. Go to mars.nasa.gov or check it out on Twitter at NASA Persevere. You can follow us, too, at Wild Thing Pod. And if you want to be kept in the loop about what's happening with Wild Thing, you can sign up for our mailing list. Go to wildthingpodcast.com. This podcast is a production of Foxtopus Inc. Our executive producer is Scott Carney. Editing is by Alicia Lipinski Lincoln, and the score and sound mixing come from Louis Weeks. I'm your host and creator, Laura Krantz.